All right, today we're going to dive into one of the most powerful and frankly revolutionary ideas in all of modern AI. It's called the attention mechanism. You can think of it as the secret sauce that lets AI models understand language with a kind of nuance we've never seen before. We're going to break down exactly how it works.
When you really think about it, it all comes down to focus. For an AI to truly get what a sentence means, it can't just treat every single word as equally important. It has to know which words actually matter for the context. Let's look at a super simple example that makes this crystal clear. So, check out this sentence. For you and me, this is a piece of cake, right? We know, almost without thinking, what the word it is referring to. But for a computer, well, that's a whole different story. This is a real puzzle. Is it the dog or is it the cat?
So how on earth does a machine solve this? It needs a way to figure out the invisible thread connecting it all the way back to dog. And believe it or not, this exact problem, learning how to link words and understand their relationships even when they're far apart in a sentence, is precisely what the attention mechanism was built to do.
Okay, so let's pop the hood and see what's going on inside. How does an AI actually learn to pay attention? We're about to look at the really elegant core idea it uses to connect all these dots. So here's the fundamental concept. Imagine it's like a dynamic scoring system. As the AI is reading a sentence word by word, the attention mechanism is constantly scanning every other word and assigning it an important score. Words that are super relevant get a high score, and words that don't really matter get a score of pretty much 0.
And the way it does this is by creating something called a weighted sum. Now, that might sound a little technical, but the idea is actually super intuitive. It's like the AI has a volume knob for every word in the sentence. For the really important words, it cranks the volume way up. For the irrelevant ones, it turns the volume all the way down. It literally tunes out the noise so it can focus on the signal. So, how does the model actually calculate those scores? How does it know which volume knobs to turn up? Well, it uses this incredibly clever system that's actually inspired by how search engines work, and it involves 3 key ingredients: a query, a key, and a value. Let's break down this recipe. First up, you've got the query. The easiest way to think about the query is to imagine the AI asking a question about the word it's currently looking at. So in our example, when the model gets to the word it, the query is basically asking, hey, who or what does this it actually relate to in the rest of the sentence?
Next, we have the keys. Every single word in the sentence gets its own key, and this key acts like a label or a tag. So when the query for it asks its question, the model compares that query to the key of every other word, like dog, chased, and cat, to see which one is the best match. A strong match means high relevance. And finally, we have the values. Now, if the keys are like the labels on a set of file folders, the values are the actual information inside those folders. They represent the real substance, the meaning of each word. So once the model uses the keys to figure out which words are important, it uses those scores to pull from the values of only the most relevant words. So let's put it all together. First, a query asks a question about the current word it. Second, that query is compared against every key, dog, cat, etc., to get a relevant score for each one. Third, those scores are used to create that weighted sum of all the values. In this case, dog gets a really high score while cat gets a low one. The final result is a new understanding of the word it that is now packed with the context from dog, telling the model exactly where to pay attention. But here's the thing, right? Language is messy. It's complex. A single word can have all sorts of different relationships at the same time. To really capture all that richness, the model needs a way to look at the sentence from a bunch of different angles. And that brings us to an even more powerful version of this idea. And that is the concept of multi-head attention. This is where the real magic happens. Instead of running that whole query, key, value process just once, the model does it many times, all in parallel. Think of it like this. Single-head attention is like one person reading a sentence. Multi-head attention is like a whole panel of experts reading that same sentence together. Each head or expert can learn to focus on something different. One might track grammar, another might track who did what to whom, and another might track the overall meaning. It's so much more powerful. So, okay, queries, keys, values, multiple heads. Why does any of this technical stuff actually matter? Well, because this mechanism isn't just some small improvement. It is the fundamental breakthrough, the spark that ignited the entire generative AI revolution that we are all living through right now. The attention mechanism is the absolute core engine inside what's called the transformer architecture. And that architecture is the foundation for pretty much every single major AI model out there today. It's what lets them handle massive amounts of text and understand context that stretches across paragraphs, pages, or even whole books. Seriously, every time you use a tool like ChatGPT or see an image from Midjourney, you are interacting directly with the power of this incredible technology.
And that really brings us to a final and pretty crucial thought. For so many years, the biggest challenge was just getting AI to pay attention at all. Now that it can focus with this incredible fine-tuned precision, the question has totally changed. As we build these unbelievably powerful systems, we have to start asking ourselves, what are we training them to focus on? The answer to that is going to define the entire next chapter of artificial intelligence.